All right, welcome to week 91, building my own operating system. Today we are going to be working a bit on some unit tests. Last week I worked pretty hard on trying to even allow for unit test infrastructure in the build, and actually it was pretty broken. I thought it worked, but in last week's stream I was only testing with basically the intermediate kernel lib library that I made didn't actually have source code. It was a header only library. What's up, Windows 1.0? So basically, yeah, last week the intermediate library was a header only library, and so that means actually some problems with my build were not visible, basically. And as soon as I tried to add C++ source files to the kernel lib, that's when the whole build system blew up. And so I'll walk you through a little bit of what happened there and what it looked like. And I also actually did a bunch of work this week to try to fix this in the meantime. And I actually have a pretty good setup now. Yeah, what's up? I do not know how to pronounce your username, but what's up, RHD? Yeah, we're streaming a little bit earlier today. Got an appointment later that I need to get to, and so can't make the usual time, but still wanted to get a stream in. So basically, just to show you, this is what the build looks like now. And so formerly, I only had one build directory, and everything was in there. It was mostly just the kernel, basically, but I'm starting to add these unit tests now, and sorry, my YouTube dashboard looks a little bit strange right now, but yeah. So now that I'm adding unit tests, those run on the host system, not for the cross-compiled target. And I was trying to do all of that within the same build directory, and it sort of majorly failed. And so now check it out. So now I have these two directories. It's build host and build target. And I can do a make. And I also have this helper top level make file, which just has a bit of convenience. Oops, sorry. Convenience helpers. But now I'm really doing more of this like super build sort of strategy, where I actually really have separate build directories. And I believe this is a better way to do it. It's actually supported by CMake. These hacks that I was doing were not officially supported. And let me just do a make clean. So now I can, for example, if I just do a make, it'll hit the all target, which will run the target and the target and the host. I'll just compile the target for now, so I can do make target, and that's just going to use the CMake preset, which I can show you, and then just build it. And it goes super fast because I actually enabled my C cache now. But basically that builds the kernel elf to kernel ISO. Okay. And then we end up with, all that stuff happens in the build target directory. I can also do make host, and then that builds the kernel lib test and uses catch 2 and stuff. And yeah. And then that's totally separate. That's in the build host directory. And then now I can run my unit tests, and that executes on my host system. So yeah, so basically that's sort of a bit of an overview of what I've been working on. Today I'm going to go a bit more in depth. My first priority is to kind of make this a bit more production ready. I was sort of just hacking it, and I want to yeah, kind of clean up the Git history a little bit, make that more production ready. And that's going to be what we'll start off with. And then after I finish with that, hopefully there's enough time, we can actually start using this to really start writing some unit tests. And we can start doing that with the bitmap allocator. And I'm just going to put a test 0 in the chat, just not for any particular reason, because the widget's already working, just because it's kind of a habit. All right, let me clean up a few of my windows here. Let me restart the break timer. Okay, so let me see. Let me clean up a few things here too. Seems like a couple of my keyboard shortcuts are broken. Okay. So just to explain, we're focused on the whole idea. So I added this thing called kernel lib. And kernel lib is a library that is going to host parts of the kernel that do not have a direct dependency on hardware. And so they're basically just sort of generic pieces of code, and there's no reason why they can't be run in user space also, for example, on a host system for testing purposes. And so that's what I made last time. And the first thing in there is this thing called frame allocator.hpp, which was what we worked on a few weeks ago, which is a very simple physical memory allocator, frame allocator. And it does not depend on hardware. All it requires is a memory map, some memory map data structures, and then it just manages an internal bitmap and uses that for its allocation. So it's a great example of something that does not depend on the hardware. And the C++ file is just sort of stupid. It's just to test what happens if I actually have C++ code in this library. And then I have my test file, test frame allocator.cpp, which actually uses catch2 and includes frame allocator.hpp, and then runs some unit tests against this class, basically. And so it instantiates a bitmap allocator under some various conditions, various input conditions, like different kinds of memory maps. And then we can do checks against the API and see how it behaves. And so these are just 2 example tests that I made, but ideally we would add some more. And here's what the CMake list looks like now. So we're adding kernel lib, we're adding a source file, we're passing the include directories, and we're linking against a couple dependencies. And so the frame allocator depends on frig for the bit set currently. And so we depend on that. We also depend on the lemine header because we need because L memory map span is just like a utility type over the lemine, this lemine type. And so we have those dependencies. And then furthermore, if we are in cross-compiling mode where we're targeting the target hardware, we're going to conditionally add 2 more dependencies. We're going to conditionally add the freestanding C and CXX headers. And these are going to be used when we are building the actual kernel for the target hardware. But the reason it's conditional is because when we're building the unit tests on the host system, we do not need to provide our own C and C++ headers because we are developing on a host that provides those. And so I don't want to include these dependencies if we are not cross-compiling. And then we have this thing. We add if we are not cross-compiling then we add the target for the test binary. And here's where we include our source files for the test binary. We link it against catch2 and kernel lib. And then I'm just adding the -g flag for debug info. So that's sort of the setup. And that's, yeah. So basically, yeah, I'm just gonna start cleaning up the Git history. Let's just take a quick walk through the history and see what it looks like right now. So I'm on this branch called kernel lib framealloc to whip because it originally started out with just trying to add the frame allocator, but then I want that to be in the kernel lib. So, and then things sort of got like out of control. There's a couple different parts of this branch. So just walking from the beginning, there's some random little commit. We actually are going to remove the freestanding C headers dependency implicit, like in frig, for reasons it describes in this commit message. This is just a little cleanup, rename lemine cpp to lemine requests. Add kernel lib. This is adding basically just the empty kernel lib. There's without any source files. And then later in the branch, we'll add the actual frame allocator files, but I wanted to separate these two things out. But here's a major problem. This is embedding the previous approach I was using, which used this like weird reset to host toolchain hack. And actually, yeah, I don't want that. Make kernel lib. And then, so now I'm doing some changes to assert.hpp to kind of migrate it into a place where we can actually move it to kernel lib. Because one of the interesting parts is that assert.hpp lives in kernel lib because frame, I want things in kernel lib to be able to assert. That's something I want to be able to do inside my code here, which means it depends, the kernel lib is going to depend on assert.hpp. But the interesting thing was previously assert.hpp directly went into a CPU loop, and so it was completely directly coupled to the hardware. And so what I've done is I've decoupled that, where if an assertion fails, it calls this assert failed impl function. So rather than directly going into a halt CPU loop, it calls a function, which then can decide what to actually, like how to actually respond. Because in the unit tests, we can't just do this. In the unit test, we want to just do a normal kind of abort or something like this when an assert fails. But in the actual kernel, we do want to go into a halt CPU loop. And so we need to decouple these things. And so that's why I've separated it like this. And the way it works is that the client binary needs to provide the definitions of assert failed impl and panic impl. And in the test binary, it's just these will be implemented with simple, like a std abort with printing some stuff to the C error. And then in the kernel, the assert.hpp looks like this, where we're going to log something and then hit the halt CPU loop, which is going to depend on the halt instruction being accessible. Okay. And so now, so basically I'm just kind of migrating and splitting things away. So now I've moved assert.hpp into kernel lib. And then this requires the kernel gets a dependency on kernel lib now. Adding the assert.cpp to kernel lib. Okay, then here's the, yep. Yes, this branch is still kind of chaotic. This thing can be moved like all the way down to the front of the branch, basically. This is just sort of a random tool I added for myself to give me some helpers. And so there's no, all that, like all this little stuff can happen at the start of the branch. Okay, so then what about this? Memory types.hpp. This is in kernel lib, right? Because frame allocator depends on the phys adder type, right? So that needs to be in kernel lib. So in this commit here's where we add the frame allocator and these files that it depends on. I'm just going to rename this to kernel lib to make that more clear. Then here's a bit of a random fix. We want the actual kernel to not declare its own phys adder type, but use the one in memory types from kernel lib. And this needs to happen after it gets added to kernel lib. Here's a drop me commit, which is just an example of actually using the bitmap allocator in the kernel. And this is not really going to be in this branch, which is why it's called a drop me. This branch is all about adding the phys allocator type with its implementation, its header, and its tests. But we're not actually using it in the kernel yet. So that's why, but it's useful just to have some client code that actually tries to link against it. So that's why it's a drop me commit, and I will delete this before merging. This is a very random commit, just enabling C cache. For some reason it was commented out. So that can also go really far to the front of the branch. Okay. Basically, I'm just trying to move things and separate things out, and just identify what. Okay, this is also a random cleanup that also goes to the front of the branch. Okay. There's a drop me. Here's another drop me commit. So this is the code that is adding C++ to the bitmap allocator. Here's some other completely miscellaneous cleanup commits. I think these all can move to the front of the branch. This is also a random fix-up using a glob, and this is all useful to do because it makes this commit a little bit more readable if I do this refactor first. And so this can also come all the way to the bottom. Maybe, I don't know. Okay, what's next? So then here's like the serious actual commit. This is the commit that it properly implements the separate host and target builds. And this is the commit that is, it is, for example, it's adding a toolchain file, which we were not using. And so for the target build, we're going to use a toolchain file. And for the host build, we don't need one. Right. So, and here's this is the thing that got added in that commit earlier in the branch, and now we're just deleting it again for no reason. And probably what I will do, I'm just trying to think about the best way to avoid a merge, a conflict resolution. Probably the best, what I'm gonna just try doing is I'm just going to actually delete this hunk from this commit. So I'm just gonna, in this hunk, we're deleting the, like, sorry. So this, no, one more, add kernel. Here's the commit that adds this hunk. And then later on in thing, and I actually don't want this in this commit. And later in the branch, we're removing it. So what I'm going to do is first, I'm going to remove it from this commit. I'm going to remove this hunk later, and then I'm going to remove it from here. And I think that will prevent a merge conflict. So I'm going to remove patch from original commit. And then, so now if we go back to lib.cmake, we're going to see this here. And now I can just go into here and do sort of the same thing. I can then remove this hunk in the same way. Now there are some conflicts, so let's check those out. Okay. I was trying to avoid this, but okay, so what's the difference here? We just need to remove this line, basically, and then accept the incoming change. That's actually kind of messed up. What? So we need okay. So the code just needs to look like this in the end. Why is my thing popping up? It's so weird. Oh, CMake is trying, the CMake extension is trying to configure. Oh, it's trying to configure itself automatically every time I save this file, and it can, apparently it cannot configure itself for a reason I can't really read because I don't speak this language. Okay, maybe that's kind of annoying. I'm just going to disable the extension for now. Disable, okay. What's up, hello code? How much you charge for this? I'm only the first user. Oh man, I don't know. I'll need to think about my pricing for my new operating system. So what's up, Saran? But I appreciate the encouragement. Hello, code. I'm glad you're super enthusiastic about trying out this new operating system. Okay, so basically I'm resolved that merge conflict. Okay, good. So now, okay, so now this looks a bit better. This is a random fix that needs to be at the end. So I'm going to put my random fixes towards the end. These two are random fixes. This is a drop me question can. I mean, this is kind of a, I mean, really what I should do is I should change this. If I want to test having code in the C++ file, I should just move things from the header into the C++ file. The only reason I had them all here in the header is because I was being kind of lazy. So that would probably be a good first step. So what I'm going to do is I'm just going to revert this drop me commit. I can delete it later, but I just wanted to do that in a non-destructive way. And now I'm going to go to, let me clear this out, frame allocator HPP. frame allocator CPP, right? And there's basically nothing in this file. And so I'm just going to start by including frame allocator to HPP. And then now I can, and I even wonder if, yeah, move definition here. Wow, that completely did not work. Wow. Okay. I was really kind of hoping for more from this refactoring plugin. So that's just an example. I'm just gonna stage these. So now let's try that again. Move definition. That is so buggy. That is wild that it's that buggy. It just copies yeah, that's pretty wild. So I guess I'm not going to use that refactoring thing anymore. I'm just going to do it manually. Okay, cool. And last one. Okay, cool. So this is, yeah, so now we're actually moving the implementation into the C++ file. And so 15 people in the chat right now. That's cool. So what's up, Scraticus in the Twitch chat? Just quickly reading this comment from Scraticus. I was thinking about the OS project made me think of new anti-cheat securities for games, which are kernel level access to ensure cheats are not being used. Is there a way that cheats can be more easily detected or otherwise dealt with from the OS point of view, or would the additional complexity just open up more gateways? So, I mean, I'll just start off by saying that I'm really not that knowledgeable about game cheating or how kernel level anti-cheat works. So I'm not really sure I can answer this question well. Also, our break timer just showed up, so I'll take a 20-second stand up and stretch break, and I'll be right back. Okay, what's up, Abdullah? I mean, about cheats, is there a way cheats can be more from, I mean, I don't know. With the additional complexity, just open up more gateways. I mean, I feel like that's always going to be true. If you add more complexity to the kernel, that adds more possibility for things to go wrong. Maybe an interesting question there is there a way OSs can be designed to provide stronger anti-cheat mechanisms to user space? I don't know. Yeah, honestly, it's a good question. I'm not really super well equipped at the moment to answer it, but thanks for the question. Okay, so now back to this a little bit. So now the interesting thing is assert is no longer used in this file. It's actually only used in the C++ file. Lemine util is needed for the L memory map span. Memory types is needed for the fizz adder. Bitset needed and optional is needed. So this is looking better. Let's give it a test. Okay, so I broke something. Oh, okay, oh yeah, I merged. Wow, I merged this really wrong. So this needs to be here, and this goes away. So that was kind of a bad merge. Okay. Now back to over here. Let me just try to build. And so now this is interesting. Okay, what's the linking kernel elf, undefined symbol, CXA begin catch. So something in it here is triggering some symbols to be used. That is pretty interesting. So let me what I'm going to do is I'm just going to stash this in the form of committing it and then reverting it. Does the kernel even build? Yeah, so it's taking a step back quickly, and so I've just reverted those changes. So now we're back in the state where frame allocator to HPP has everything, and the C++ file doesn't really have anything. And everything builds. Both the kernel and the unit tests build. But something I did here triggers a call to these runtime functions, and I'll just delete this commit. So now I'm curious about that. So now I want to go into the target, and I'm not really sure if this will work necessarily, but so Linux Gooner, currently solving total confident questions on code and C. Can't imagine writing OS, but I'm learning a lot from this stream. Cool. I'm glad you're learning something. I don't really know if I'm being the best teacher right now, but yeah, I mean, it's all a step-by-step process. I've been doing this for almost 2 years now, and a lot of what I know about what I'm doing right now is things I've learned along the way. And so I think it's definitely doable for people to learn this stuff. Okay, what I want to do, I don't know if this is a good idea. And let me go back here to, I need to source the env setup.fish in order to get access to the read elf. What's up, King Waleed came. Very excited for what you're building, because very mature goal for every developer to have their own OS. Best of luck. Thank you very much. Yeah, I agree. It's the goal of every developer. So I'm just going to try to disassemble this, and maybe this is an awful idea. And how do I get, and how do I CPP filter? That did not really, I was hoping to demangle those symbols. I thought CPP filter did that, but apparently doesn't. So now I'm just disassembling the object file, and I'm just curious, what what in my code is causing this to happen? And why is it only a problem if I put it in the C++ file, but not the header? So terminate. And I haven't been using Miro today, but I'll make a little workspace to record some of these problems because this is kind of interesting. Yeah, Linux Gunner, if you're still around, I'm actually curious, what specifically are you learning about that I'm doing? I'm like talking about random build system stuff, but yeah, just sort of curious about that, if there's anything in particular that you're learning at the moment from this. Saran asks about the UI. UI is probably the lowest priority thing for me right now. So I'm not really focused on this. I could eventually envision that we do have a UI, but I'm not super interested in that, and I'm gonna prioritize pretty much everything else over doing a UI. Moving the frame allocator code into the CPP file from the header causes this linker error. Qt, using Qt for the UI. That would be pretty difficult because then I would need to port Qt to the OS, which would, I think that would basically mean I would need to support a lot of POSIX to make that work. And that sounds kind of like a lot of work that I don't necessarily want to do. So it'll probably be more of a custom UI than using Qt. Maybe there are some libraries I can use though. Yeah, I mean, the UI is really not that necessary. There's a lot of other things. The linker, what is triggering these symbols? And the interesting thing is there's this terminate function defined, but I'm searching for the word terminate in this disassembly, and I am not seeing any calls to this terminate thing. So maybe this is a good opportunity to get our friend Claude running in here. Is it open sourced or not? It is not currently open sourced, but maybe that will change in the future. Dang, escape to interrupt. I want to add more context. What do I want to say? I got these linker errors after moving code from frame allocator.hpp into frame allocator.cpp and linking the kernel elf target. I'm not sure why there's a difference between putting it in the header or CPP. In the disass of the object file for the CPP, I observe a symbol being emitted, but it doesn't seem called. It's in the section. So I'm going to let Claude work on that a little bit while I also think about this a little bit more. It's my day-to-day job, if not secret. I work in the music technology industry, and I work on software and hardware for like music production, basically, for making electronic music. and I don't work on a custom operating system for in my day job. Okay, so now it's asking me yeah, okay. It's gonna ask for obj dump which you may need instead. Okay. So claim, okay, so now it's all right, so now it's disable C++ exceptions. Oh, is that interesting? Kernel lib does not inherit the base CXX flags. Let me take a moment. So toolchain. So we do have these base CXX flags here. And at least, okay, I see. But then kernel lib. Right, so we're not current CMake lists, CX flags. Wait. Who? Okay, the kernel is using these, but not kernel lib, and that is interesting. So do not stop. I will not stop. Yeah, no, I'm gonna, this is a lot of fun still, so I'm gonna keep going as long as I can. So it's interesting, the kernel is using these flags, but the kernel lib is not target compile op. So I think we need something very similar here for kernel lib actually. Okay, I have a follow-up question for the AI, but let me post. So if not cross-compiling, and if, or if, wait, what was it? If it is cross-compiling, we want to if we are cross-compiling, we also want to apply these flags to the just taking the Twitch chat. Oh, Scraticus, you lost your job. Damn, dude. That's a bummer. I'm sorry to hear that. Completely blindsided. Crazy. Yeah, I hope we can find another one. I hope we have some savings. And sorry to hear that. Sub Sharfak, bro, how much time to get to your, how much time it took to get to your level? Yeah, I mean, dude, I've been programming for over 10 years. I've been programming for like probably 13 years at this point. And so that's one way to answer the question. In terms of OS knowledge, I've gotten a lot of it from the last 2 years of just trying to work on this project though. I did have a lot of experience in general before learning OS dev specifically, but I have radically accelerated my learning in the last 2 years just by doing this project. Okay. So basically, yeah, kernel lib, if we are cross-compiling, we want to pass some flags. And actually, so the question though is, do I want any of these flags otherwise? I don't really remember what these things do, but I'm gonna say no. I'm gonna say let's just not use them. So now let me try again. I'm gonna try to build the host target and check it out. That actually worked. And just to demonstrate that if I comment out this chunk of code, our host build, wait, what? It's still, wait, what? That doesn't make any sense. No, our target build, sorry. Our target build target, right? So let me put this back in. Also, what's up, Michal? Nice to see things moving. Yeah, I feel like I'm just pretty excited about the progress we're making on the build system and unit tests and stuff like this, and I think it's going in a pretty nice direction. Okay, let me try building the target, and that worked. Check it out, that worked. I'm going to comment out this chunk of code and let's recompile. And that failed, and that's exactly what I was hoping to see. And so that just reinforces the point that, okay, we need to make sure that for our kernel lib, if any code is going to possibly be linked into the kernel, it also needs to use our kernel C flags and CXX flags to disable exceptions and whatnot. So yeah, so that's cool. And now we can build the target. So check that out. System is unknown to CMake. Create to use a system. Please post your config. Interesting. I think that's because I set my system name to be called, like my system name, system cross tool chain, to be called my kernel. Maybe that is not the right thing to do. It was called generic before. Maybe that is actually the right thing to do. But okay, one thing at a time though. So let me so this is important. And this commit, this hunk is going to go into this commit. This is the commit for properly adding support for the 2 different build directories. Right. So I'm just going to amend this into there. Perfect. And so now, things are building, right? So I'm going to ask my follow-up question to the AI. Why would, thanks, that fixed it. Why would moving code from the HPP to CPP trigger this issue? Usually in cross-compilation, you want the same flags unless the host, that's a very, yeah. Yeah, let me just see. When the, this is interesting. When the code is in the header file, it gets inlined into the client, and so the compiler can see the full context and can optimize away exception handling machinery. But when moving things to a C++ file, it's in a separate translation unit. And so therefore, that limits the extent that the compiler can optimize away exception handling. And therefore, it must just generate the exception handling symbols and stuff like this. That is interesting to learn. I'm gonna save that in the mood board, because this is a mood for sure. Got my OBS screenshot in there. Okay. So now I can come back. So now I'm going to soft reset here, and I'm going to amend this hunk into here. So I had this code, the drop me, then I reverted the drop me. So now I can just directly amend into this commit. I'm gonna abort the rebase. Let me just see what happened there. So, okay, 20-second. Feel free to join me for a stand-up and stretch. Okay, so nice. Still got 18 people in the chat. It's more than usual. That's cool. Unfortunately, I think I got shadow banned on Twitter. Like, I've been tweeting about my streams, and it's like no one sees them anymore. It's crazy. I think I got shadow banned or something. Okay. Whatever. Back to this. So, what's up, Icron? Nice to see you again. Hope you're doing well too. Yeah, thanks. The shirt designs. I'm wearing one right now. This is the Taiwan Semiconductor Manufacturing merch, and I'll just leak this on the stream right now. You can, if you want to support me, you can buy some clothes. shop.offlinemark.com. This is not completely publicly announced yet, but oh, nice one, yeah. But yeah, so anyway, Icron is really in the know. This is not completely publicly released yet, but if you want some clothes, you can buy some from my new clothing brand. I got the Taiwan Semiconductor design. I have the Intel Virtual Memory Witchcraft t-shirt. I designed this new Acquire Release shirt, which is a reference to programming with atomics. So anyway, leaked my clothing store, but feel free to check that out. Okay. So that was just merge conflicting, unfortunately, but here's what I'm going to do. I am going to just simply drop. Okay, I'm going to revert this one. I'm going to drop this commit. Okay, now I'm getting. Okay, now I'm getting conflicts everywhere. All right, let me see what conflict happens when I drop this. It's just this massive conflict. And but the interesting thing, fix up, so this commit adds everything here. And the thing is, I thought I basically got rid of everything here. The conflict happens when in this commit, I see. Here's what I'm going to do. I'm going to delete this. I'm going to soft reset here. I'm going to stage like a normal person. Move, rather than doing this weird revert stuff, to move from HPP to CPP. Now I can delete, now I can drop this. Now I can drop this. Now I can go back and on, that's such a, on, why, what's up with that? Okay, now I can apply the stash entry. And lastly, now I can amend this back into this commit. This is the one that adds the empty file in the first place, and I want to actually add. And now we're getting some conflicts, but hopefully they're not too bad. Interesting, we're getting conflicts in the header, and it's the conflict is just that I think the conflict is the assert false here. No. Yes, the conflict is this random assert false. Okay, so basically all I want is the current change actually. So that's the resolution here. And maybe once more. What's the commit? Add filling, yeah. So now, again, we're just gonna go with this. Cool. And frame allocator. So now here's our commit where we add this header, and now stuff is moved into here. Sort of, yeah, okay. Fix bad merge. So now the fix bad merge, this is, I'm going to soft reset, and then now I'm going to, I'm pretty sure this just gets amended into here, I think. Yeah. So now here's what this looks like. As part of the process of migrating to this whole cross-compiling separate build directories thing, I am properly actually wait a sec. Technically, I think this would come even earlier. You know, it is sort of funny how I have 2 commits. I have 1 commit that just adds kernel lib in a very naive way. And then this whole thing, probably a lot of this commit needs to move into here actually. And even, I mean, just looking at this, this is even sort of a cleanup that can move earlier. Hey David, what TUI is this? This is called lazy git. It is the best Git client, basically, as far as I'm concerned. Okay, it is an extremely good Git client for doing things like rebasing and cleaning up your Git history and moving hunks around and splitting commits and doing stuff that I like to do. I consider it kind of like the Vim of Git clients a little bit, because it's like kind of it's like a little bit obscure to learn how to use with all the commands and keyboard shortcuts and stuff, but it is very, very powerful once you learn it. Okay, move assert. Yeah, okay. So yeah, this commit, a lot of what's in here ultimately needs to make its way into this one, basically. So let's see how we're going to do this. Again, I want to get this stuff out of the way. This is like a drop me. This should go towards the end of the branch. This is the one that actually adds the frame allocator. I'm just curious, how terrible are the conflicts going to be if I try to move this down to here? Let's just see what's in this commit. So I'm changing the kernel lib CMake to actually have correct support for cross-compiling. This, like what I did in that earlier commit, was completely incorrect. I'm adding my cross toolchain file. I'm sort of tweaking my existing toolchain file. Basically a bunch of stuff needs to move into the cross. It's actually kind of an interesting situation. Why do I even have these 2 things? Why can't I just keep using the normal one? That is an interesting question. This stuff, so catch 2, the thing is catch 2 got added earlier, so that's all right. So wait, so that and this, so I'm going to, all right, I think most of this can move in a very clean way. I'm just going to start off kind of conservatively. I'm going to take all these changes. I'm going to split them into another commit. Now these got separated into this SDF commit. I'm going to move this all the way down here, and yeah, and then I'm going to fix it up and squash it into this commit below. Oops, check out and so this add kernel lib commit is ultimately going to contain or maybe even I can separate things out. This could even technically maybe be, and the presets is maybe even a separate thing. I'm going to separate that out too. This helper thing is even separate. That can be separate. The git ignore, but this is just convenience stuff, so I'm going to even separate that out to move into new patch. Convenient. This is not part of the core work here, and so what I'm trying to do is, it takes a lot of changes to do what I'm trying to do with the cross-compiling and stuff in the build system. And I'm trying to split these into commits that are as small as possible, so I don't have these massive commits in the Git history, which are impossible to read for anyone trying to read the history, which will basically be me in the future when I'm trying to understand what I did. And so it's not just for a collaborator kind of situation. I'm doing this effort because, for one thing, it helps me clarify what I'm doing better, but it'll be helpful for me if I want to ever understand how my project evolved and took form the way it did. It'll be helpful to have an easier history to read through. So this commit can really come, I'm going to move it all the way to the end, basically. This is like this not very substantial convenience helpers kind of thing. It's separate from the core work of doing the cross build. Here, I think even reset to host toolchain, this is also interesting. So I could imagine, I mean, this is also kind of separate. Ignore. And this is like legit changes. So this can even go way at the end of the branch. Again, not super substantial. Can I move this down? No, that conflicts. Okay, no conflict. These two things I can also well, this was really the open question. What why, like, do I even need, I don't think I actually, So right now, so tool change at CMake contains a subset of the total toolchain changes that are relevant in any case. Okay, so it actually maybe is still useful to keep. Cross toolchain these are the settings that truly only apply for the cross compilation situation. All right, so I guess I'd still do want, it does make sense to have both of these around, but this stuff also really only applies for the cross. Okay, so yeah, okay. This part of things is a little bit of a mess. I'm just thinking when would be the best time to clean that up. For the moment, okay. I think for the moment I can still continue. I can separate this out. So these are these toolchain things. I can also move this down really close to where these three commits will all get sort of squashed, I think, but maybe not. So this is separate. I'm going to move this out. Real changes. These real changes. Okay, so this commit is just, it's adding cross-compile support for catch 2 and CC runtime. So that'll be a separate commit. Add cross-compile support to catch 2 CC runtime. we only want to, okay, add kernel lib, then these toolchain changes, quote unquote real changes. So now this basically just leaves this hunk. And this probably conflicts with this commit. Okay, so let's just see what happens. I'm going to move this commit like pretty far down. I'm gonna move it to here. And let's just see what the conflicts look like. So conflict number 1. Okay, so I think I think the way this is going to be is we're going to have an empty set. At this part of the history, we're going to have an empty set of, we're going to still have this line, but we're just going to not declare any things right now. And moving down here, this cert stuff comes later. So right, similarly, we're going to add the executable, but it'll also be an empty set. Actually, I'm gonna back out of this. Let me quickly rethink this. Right. So we add the kernel lib here, but the tests actually can kind of come later. Wait, kernel? Okay, I'm gonna split, I'm going to split some more things out. So we're just gonna have a pure kernel lib in this commit, and a kernel lib test will come a little bit later. And I'm going to move this up to here, right? So we add, okay, some tiny preparations to the third-party libraries, add kernel lib, very small commit, doesn't really do very much right now. Real cross-compiling changes, whip. Tool chain changes, okay. Moving, okay, so these two things clearly follow. Add kernel lib, move assert.hpp to kernel lib, that's a really small change. Add kernel lib test. And seems like there is a stray line at the bottom. I'm just gonna, okay, try to remove that, but something didn't like that, so, okay. Add assert.hpp to kernel lib test. Then here's where we add the frame allocator. And then this thing needs to come before though. And that's sort of like this crazy conflict I was running into. Or I could relax like a little bit and just live with more things being clumped up in the history into this commit. Although this commit is already kind of big, so I sort of didn't want to do that. The point of this commit is to add the source file, link the necessary libraries, and so so when I resolve the conflict, I'm going to not even include this at all. When I move it earlier in the history, this hunk will get completely just added by this commit. But actually what this commit needs to do though is it's responsible for adding this part. So we're gonna have a kernel lib with this part actually right, and then, okay, I see. We're gonna add this part first, and then this commit will just add these two things later. Okay. So that's one part of the changes. Then we have this separate thing here. So this pretty clearly, I'm going to even split this out. This pretty clearly belongs just below. I even wonder if I can move it without conflicts. Yes, I can. That's cool. So actually, I think it's going to just get. Here's our commit where we just add the kernel lib test basic kind of layout, and an important part of this is this thing. So I'm just going to fix it up and squash those two things. So good. So add executable. And so then some options. Nice. Okay, let's keeping going. So at this part, which we can resolve in the merge conflicts. And what about this part? This part is all about. This part is about wrapping something in a not cross-compiling guard, basically. And that also needs to happen right here. And just thinking the best way to actually do that. What I might do is revert this hunk. Yeah, all this is doing is moving these three things into the if not cross-compiling guard. It's just simple movement. And I wonder if or what I could just do, and it might be easier just to do it this way, is I can just come back, I can just add the change here and then resolve the conflict later. I think that might be the easiest way to do this. So I'm going to rebase and stop back at this commit now. And what I want to do is I'm just going to copy this. So now I just want to, now I'm kind of back in time, and I just want to add this. Here. No, wait. It needs to look like this. Kernel lib has its own section right here. Kernel lib test has its own little thing, and I just move these things into the guard. And I'm going to amend this. So we're just seeing this movement here. Why is this highlighted? Target link libraries, kernel lib test private. Okay, I'm going to amend this here into kernel lib test, then continue the rebase, and we're gonna have some conflicts to resolve, but I think they should be fairly understandable, hopefully. Okay, so conflict number 1, we're trying to add assert.hpp into kernel lib test, and that needs to happen here now. And so, right. So this goes into here, and this whole thing goes away. Good. Continuing. View conflicts. Okay, what's up next? So now we're trying to add frame allocator to kernel lib. And this involved adding, again, we want to take this file, and now it needs to be over here. And so this line comes down here. Okay. Okay, cool. And I think that's it for that conflict. And then now what's up here? So here's our here's our commit where we're doing the cross-compiling support, and it's trying to add, okay, this is like a bit hard to discern. It's trying to add these things. Okay, so this got a little bit hairy. Let's just come back and try to remember what this commit was trying to even do in the first place. It is trying to add these things to here, and this part is completely not necessary anymore because we took care of it already, and now it's sort of trying to replay that again on top of what we did already. So I'm going to start with this one since it's a little bit easier. And really just the key point of what we're trying to do here is, okay, 20-second break, be right back. Feel free to join me. Okay. The key point of what this is trying to do is it's just trying to make sure we conditionally... Ah, wait, but kernel lib. This really comes earlier in the history, actually. But just to resolve this for the immediate moment, this thing is going to come up here. And this thing goes away. Lib, and then over here, I think in this case, we just want to keep the head. We crafted this into pretty much a perfect, into just what we wanted already, so we can just keep the head. Okay. And that did it. So let's check out what things look like here. So we add the kernel lib test. We add assert.hpp to here. We add frame allocator, and this is just adding stuff. So this is the part we still need to kind of tweak. Technically, technically it should be a bit different. First, these two lines should be in this commit right here. And then this commit should just add these two lines in. Okay, this looks like a mistake. Yeah, this looks like a mistake. Too much stuff got added here actually, because this commit already completely was working, and then now I made a mistake in the merge and it's like duplicating. So that's pretty easy to fix though. I just need to delete this hunk. Okay, so now this commit only contains this. Okay, quick double check. Everything is still building, good. So nothing has been broken. The history just looks different. Now pretty much one of the last things to do here is what I described earlier. So here's what I'm going to do. And I might just do it in the same way. Or a similar way actually. So what I'm going to do is I'm going to just copy these lines into somewhere. And I'm also just going to copy this hunk into somewhere. Dang. Paste. Throw pasting into Vim. Okay, I'm going to revert this commit. No, I should not do that. I should just drop the commit. I'm going to drop this commit, and now I'm going to go back into this commit, edit it, and apply the change. And so it's going to be something that's basically kind of like this, except kind of different. We're actually going to have these two lines here. Good. that's what we want in this commit. So now I'm going to amend it and continue the rebase. We're going to conflict in here, add kernel lib test. And let's just review what did this commit try to do? It's just trying to add all of its kernel lib. Oh, that's interesting. This was actually not in the right place. This should also have been in that original commit. So actually, I'm going to copy this also. Dang. Set paste. Man, I need to figure out a better way to paste into Vim. This is crazy. Set no paste. I'm going to actually abort the entire rebase. I'm going to try that one more time. I'm going to come back into here. Actually, no, what I'm going to do is this. Yeah, this is just simply wrong. This hunk why did that conflict? I was just trying to... This hunk yeah. Wait, I can... okay. I cannot just reorder these things like that. Okay. Okay, yeah, I'm gonna do a different, so yeah. So I got this thing copied. Okay, so I'm going to just drop this commit. I'm gonna go back into here, edit the commit, and I'm gonna put in everything that I wanted there to be in there in the first place, which is basically this, except not these two things, it is these two things. Okay, so we got our basic kernel lib, it's like empty, points to the includes, it has our conditional headers, and it has our conditional C flags. Perfect. So now I'm going to amend this into the add kernel lib commit right here, and continue the rebase. We're going to conflict, and where do we conflict? We're conflicting in add kernel lib test again, but hopefully this should be kind of a different situation. This commit was just trying to add this section. That's all it was trying to do. Yeah, and now we just take both. We just take both. It's correct for this to be here. This is all the kernel lib stuff, and now we just want to add this at the end. So we're going to take both changes, and I'm going to clean up the end of this file a little bit. Yo, digitalized, what's up? Good morning. Yeah, sorry, I had to move this a little bit earlier today. I have an appointment later. And we are, yeah, just doing some serious Git surgery right now. But the history is going to look amazing once we're done, and we're pretty close. Just quick check that the build. We have no make file. Let me just. So we're going to just finish resolving these conflicts. Now we're at a conflict with this commit. And all it's trying to do is just add these specific things for the frame allocator, and we are probably conflicting on this hunk. And so all we want to do is take these two lines and move them up here with a space, I guess. That's all we want to do. Clean. This is going to look super clean. Okay. And bam, So that's very close to our final history then. So let's just look at the evolution of this code. And so oh wait, nice. Nice. So I mean, this branch ended up kind of long, but it's just a lot of these little incremental commits that clean. So first off, there's just this early section of the branch where it's just like a lot of little cleanups. I add a little helper script for myself. I uncomment, I like add back the C++ Ccache support because I don't know why I was commented out, but whatever. I remove just some comments. I just clean up another. I mean, this could even be squashed into. No, can it? No. I remove some more comments. I remove some more unneeded variables. I just move this thing a little bit higher in the file because that's actually important. I use, instead of specifying a million file names here, I'm using the glob function, which will make a later commit much easier to read. I remove a dependency from Frig for some reason. I do a light rename of a file from lemine.cpp to lemine-requests.cpp. So you can see that there's a lot of commits here, but they're all really small. They're all really easy to review because they're all just like these separate operations. Now I'm making assert.hpp hardware agnostic, which is also in preparation for a future commit. Adding. So now here's where it gets into the more of like the cross compile stuff. Too much lazy get candy, it makes my head spin. I hope the final pass that will commit on each stage. Yeah, and it's really, I mean, the lazy get part is just to make all this easier. You can just do this with normal Git. It would just be like way harder. But yeah, this is very close to the final patch set. Adding, so here's where we just add a bit. Here's where we make the third-party libraries cross-compile aware, which is just catch2 and cc runtime. They just need to know to we don't want to, wait, if we are cross-compiling, we want cc runtime. If we're not cross-compiling, we want catch2. So now here's where we add kernel lib. And this starts out as just a super small commit, like super empty. We just add this little kernel lib subdirectory thing. And we add a CMake list.txt file with an empty library, but that's pretty much configured, ready to go. And so it's configured with its includes, it's configured with its conditional dependencies based off of the cross-compiling state. And lastly, it conditionally configures the compile options based off of the cross-compiling state. And that's it for this commit. And we slowly just evolve it a bit further. So now that we have a kernel lib, we can move assert.h into kernel lib because it will be used later on by the frame allocator. So again, super small commit. Assert.h moves into kernel lib, and then the kernel needs to depend on kernel lib now because the kernel was not depending on it before. So now we just move it, and now the kernel depends on kernel lib. Now we have a couple things I still need to clean up, and these are the real changes to support the cross-compiling. If we are cross-compiling, we want to include these directories that are relevant for the core kernel. Otherwise, we don't even need these targets. Otherwise, if we're not cross-compiling and we're just building the host tools, all we need is kernel lib and the third-party lib. Okay, this is just the tool chain settings, also in preparation for cross-compiling. We're splitting apart our tool chain settings into tool chain settings that apply when we are cross-compiling, and tool chain settings that, I mean, in general, it's tool chain settings that apply in all cases, although it's sort of only this line, I guess. So this was still a bit of a whip commit. We don't necessarily need to, yeah, can still work on that a little bit more. Then we start adding kernel lib test, which is the unit tests. And so we just add this small chunk here. If we're not cross-compiling, we're gonna add, again, an empty executable, and it's going to link to catch2 and kernel lib, and it's going to use the -g, and that's it. And then now we add an assert.cpp for kernel test, kernel lib test, which is just the implementations of the functions that get called in response to an assert failing or a panic. Then here's a commit where we actually, and this will take a bit more work too, but we actually add the frame allocator. So this is actually an example of code that's being added, the first code that's being added to kernel lib. We have the header, the source, and our unit test, and our CMake list change just looks like adding the source, adding the 2 dependencies that frame allocator needs, and just adding the test file. So that's super minimal, super small. Yo, what's up, Jason? Nice to see you, man. Thanks for tuning in. Checking out just working on my operating system. And then now we just have a couple small commits for just various convenience things. So we just add the CMake presets thing at the end, add this git ignore thing at the end, and a couple other small fixes. So yeah, I'm gonna fix this typo. So it's coming kind of together. I think yeah. So let's look at third-party stuff. Yeah, I'm still undecided whether this should be in a separate commit or not. But real cross-compiling changes, like maybe, I mean, it would probably make sense to squash these two things. So just like this commit is just a collection of changes where we really start to make use of this CMake cross-compiling thing and make decisions based off of that. And we do this in a few places. We do this in the root file, and then also here. Technically, it did start to use it here. But whatever. So, okay. Now here's the question, tool chain changes. So the idea was to make a cross tool chain file, but it pretty much ended up kind of the key part here. We remove this broken cross-compiling support. And if cross-compiling, we tack on few other these specific flags that are only relevant in the cross-compile scenario. Let me think a little bit. I'm going to think for 1 second about this. Okay, well, at least just to start out, one thing I just want to do is I want to delete this. This is our old way of trying to do the dual build, and it is just sort of broken. And so I want to separate this out into the but it kind of, why did that conflict? Remove broken cross build. Okay, I'm gonna kill the palm tree. Oh. Just to make this smaller. Wait a sec, why? Oh wait, oops, that's the wrong thing. This is what I wanted to remove. Okay, just the really, really confusing thing about the current state of the code is that there are some things that are not used. So if I remember correctly, the base C flags is used for the purpose of generating these things. Really, it all boils down to these kernel C flags. That's used in both of these files. Kernel CXX flags also used here. User C flags is, I mean, there's no user space anymore. So actually, this stuff can completely go away. Actually. That's probably even a good cleanup for earlier in the commit, but in the history. But so really the point is this random stuff, I believe it's completely unused. So just to simplify things, this can all go away. So daemon 06, lazy git. Okay. Actually, this stuff can... So the cross toolchain is going to have all of the settings that apply for the cross-compiled build. So including this stuff, Subtugra, including basically like these, it's gonna, okay. Including basically all of this stuff is really only relevant for the cross build also. Okay, so what I'm gonna do, actually after thinking about this a little bit more, the flags are possibly interesting. like there are some flags that I want to apply also for the unit tests, but then a lot of the flags only apply to the kernel. And I'm trying to think about the best way to express this, because in current CMake it's easy. We just slap on these things. In the kernel lib, it's a little bit trickier, because if we're cross-compiling, yes, we want the full set. Otherwise, if we're not cross-compiling, we still probably do want some of the core flags. So actually because currently now we're not passing any flags anywhere, really. Which is not amazing. The question is actually, where did the flags go? Do they go on the kernel lib or the kernel lib test? I'm talking, for example, it would be nice to probably have W all or something. Right? Like, that's just something I just want to have everywhere. Like, all this stuff is like kind of sort of random. Okay. Not too much time left, but I'll see how far I can get. So what I'm gonna do, this is a little bit of a riskier change. Now that I sort of know what's going on, I'm gonna drop both of these. And just to make sure everything is still building. Good. What I'm going to do is I'm gonna drop these two commits. Okay. I'm gonna make a backup because it's possible I might screw everything up right now. So I made the backup. What I'm going to do real cross, right? I think I'm just deciding whether I should do it all on like the tip and then amend it back in, or where is it? Or like rebase back to here, do the work there. And I think I can do it on the head. Yeah, I think I can do it on the head. I'll also all right, I'm gonna squash this back in. I'm just gonna do things on head. So here's what I'm gonna do. So toolchain and cross toolchain.cmake, right? It is okay. So first off, all these things go. These are unused. Second, these things all go in here. Base, these are all, again, I mean, these are things that can just really just be deleted, but just to keep it simple, everything here is really for the cross compile. That's the intention. Which means I don't need to have this branch anymore. I should not need to have this branch anymore. I should just be able to directly, right? Directly have the flags in the base C flags. Okay. And this hunk goes away also. Basically, the one thing I do need to keep is this. So now the question is, what goes in toolchain.cmake? And it's everything that I still want for the unit tests, basically. I'm just going to make... And maybe some of these names need to change. But for the moment, I'll just call it rebase C flags. Okay, so like the rebase C flags is stuff like WAll. And sort of my question now is, I guess I'm a little bit unsure about this. Real base C flags. So now base C flags is based on real base C flags, which just has stuff like WAll. No unused, I don't really know. No unused, no format. -G. Again, so these are all really these kernel types of lip. Probably with client, there's no more lip. We can get rid of that. Okay. This thing goes. Now our space. So basically now there's, so actually this thing, this thing just becomes kern C flags. Kern CFX flags. And this just comes in. I mean, we don't even need this anymore, frankly. We're not even, that's completely legacy garbage. But okay, just for the sake of time, I'm just gonna remove it. So all these things can go straight up. All of this can go. So now we have the current C flags and the current, this can also go. Base LD flags. This is actually important. So now I don't really know what this does, but I'm just going to put them here. These are very generic things. Okay. Cool. Quick test. Let's just see what's the state of things. Make target. Okay, this barfed all over the place because somehow our... Okay, wait. It's barfed all over the place because somehow the exception flag, no exceptions, current CXX flags. Kernel, damn, okay. Okay. Let's try that one more time. Make clean, make target. Perfect, that still works, good. Let's try the host. That still works. So I haven't broken anything. Okay, it's sort of interesting that I have. Okay, now here's the part where I need to, in lib.cmake, now it's my opportunity to do else. Real base C flags, real base. And so now if we are not cross-compiling, here's our opportunity to still use some flags. And I was wondering why this was actually still continuing to compile even though we have W error would be the one that fails it. But so now here's our opportunity to or wait, no, we can do this this way of doing it maybe, where we use this Boolean, but that's kind of ugly, so I don't know which is cleaner. We could technically just have a single of these statements and then we use this way of Boolean checking to like add things, but frankly this syntax is super messy and I don't really want to do it that way. So I'm just gonna do it this way right now, keep it simple. What's up, Ismail? Yeah, stream happened a little bit earlier today because I have an appointment a little bit later. So, but the CMake support, the cross compile build is really solid at this point. So Ismail, you were there last week where I kind of tried to make that work with the kernel build, but then the unit test build and like doing it all in the same CMake like build directory. And it seemed to work, but actually had a lot of problems once I tried to keep going with that. And so I've done it basically more properly now, where I actually have these two separate build directories, build host and build target. One's only for the cross compile kernel. The other one is for the only for like the host stuff. And that's really how CMake is like really meant to be used actually. And so it's more of a proper way of doing things. If I add W error here, now probably things will start not like, probably the kernel won't build anymore because actually it still did. Interesting. Does the host still build? Okay, I don't really know what's up with that, but yeah, yeah. Not everything was in the VOD because a lot of the work I just did during this week actually, but yeah, I posted a little bit in Discord in my project space about it, but here, I'm just gonna not do this. So now here's what toolchain.cmake looks like. It's very simple, and with the real base C flags, now those can just be called base C flags. Okay. I'm just gonna do a bit of a message here actually. I'm kind of not sure if these are being picked up. And how do I see this message? I'm gonna do the make clean make. Yeah, actually that's kind of bad. We're not getting the base. Interesting. So toolchain.cmake is included kind of here, but when you use, I'm using this presets.json thing, and so I'm just CMake preset target, and all that does is it comes into here and it looks, okay, let's use this tool chain file. And it seems like that runs at a very early point, even earlier than this part. And so therefore anything we define here will not be available, unfortunately. And I am not sure of a good way to handle that. So I'm just going to copy to do base C flags in toolchain.cmake is not found because this executes first. Any to do find a way to not duplicate these. Okay, but now if I try that one more time, oops. Make clean, make, but I got rid of the message, but all right, whatever. So this looks pretty decent. So now I'm just going to go into here. These two commits get squashed into here. And we're just gonna have one commit with like a lot of cross-compile stuff, I guess. So wait, yeah, okay. Add cross-compile support, which is not a good message. Support CMake target separate target host builds. That's a bizarre zib. Thank you, appreciate that. Just kind of doing my thing. Then here's the question: when does this? Also, this is wrong because, and there's no, it's kind of frustrating that there's no warnings. I was using the wrong variable name. So, and again, this is only in the host build case. So make host, and how would I observe that this is working? So I could try to make host. I could enable verbose mode, and I could try to see for the word wall here, and that means it's working. So now if I comment that out, oops, and make clean, make host, and I search back for frame allocator, not quite, one more time, and we don't see a dash wall there, so that means this is working. Cool. Okay. So now what I want to do is this thing goes into the commit that adds kernel lib, which is right here. Okay, let's go back. Shit. I'll just try to resolve this conflict quickly, then I gotta get going pretty soon. So what was the point of this commit again? This commit was just trying to move some stuff into this cross-compiling if statement. But we're trying to move this thing ahead before it. And all right, I'm not sure. I'm gonna cancel that. Here's what this commit looks like. So we have our tool chain split kind of thing. Okay, so here's technically I mean, this could actually even come down here, get merged into because we add the cross tool chain file in this commit, so it sort of makes sense that this preset thing goes into the same thing. So I'm going to just fix that up. Git ignore, sure. Support, yep, fix up. Okay, I think this is where I need to leave it today, y'all, but this branch is now in a much more readable state to understand the evolution. And just to recap what we can do now, this is how it looks. I have a top level makefile wrapper that just dispatches to CMake and with these presets and stuff like this, and I can do rmrf, which deletes the directories, really fresh start. I can do make target, and that builds the kernel. Now we have this build target directory. I can do make host, and that builds the unit tests, and then that goes into the build host directory. And then the host, kernel lib test, and it runs the unit tests. And we actually do have some unit tests. We have only 2, and we'll add some more, but that's how it looks like. And so that's where we're at now. And next time, now we can really do the frame allocator for real. Productionize this code, get rid of these raw 12s, write some unit tests, or maybe have AI generate some unit tests, and that will be that. Whew. All right, guys. Well, I want to thank you for joining the stream. I'm going to kind of wrap it up here. Discord. Feel free to join the Discord if you want. Please like, comment, and subscribe. But seriously, though, if you're not subscribed, please subscribe. And join the Discord, and have a great week, and I will see you next week. Peace.